Well, welcome back, and this is a little four-wheel cart that I was using in the previous video. It's got two DC motors at the front, just casters on the back, you can't see them from this angle. It's got a myRio 100 amp H-bridge, isn't needed of course, we use that on the bigger one, but I can just transplant it very easily into the big cart, and that might use 30-40 amps or something, so it's got plenty left over. And I've added this USB camera on the front, so the idea is now I can stream images back from it when I'm moving around the corridor. So it's a typical little robot thing. It's going to run off the Wi-Fi, the signals here, nothing special, it's a TP-Link Wi-Fi. And you'll notice one other thing, I've put a steering wheel in. Sorry, it's a bit jumpy. This is one I managed to get off Amazon or something. It's really for video games, and it's meant for PC or PlayStation. And I thought you might be able to use it on the myRio, but unfortunately when I plugged it into the myRio gave me out some daft results really. So directly it's not really that suitable, unlike the joystick I used before, which the Logitech joystick, which works really well. This one didn't work, but it does work on the PC, and you can use the joystick commands on the PC. So I thought, wouldn't it be nice to be able to use the steering wheel and steer the cart around and stream images back as well? Because it's nothing quite as simple as it sounds. This thing's also got pedals, by the way, down here, and I'm using the left pedal. It's a sort of acceleration thing, so it's like a throttle or the accelerator in a car. For reverse, I'm going to use this button here, and so otherwise it's just steering a bit like a normal car. So this is I've projected everything onto a bigger screen so you can see it. So this is the thing. It's not working at the moment. I will get it working in a minute and demonstrate it. It's a recorded image. How does it work? Well, a little bit of trouble I had here. Well, first of all, the main part for controlling the motors is just the same as before. That's really not a problem. It's just PWM, one for the left motor, one for the right motor, some digital I/O, and the steering algorithm, which uses a cos and a sine. It's very straightforward. Some scaling, of course, for the to get the information from shared variables, which I mentioned before in the previous video. That comes through the Wi-Fi. Now the image uses iMac, and you initialize, you open the camera, you do a grab, tell it it's continuous because it's going to be image, and I put in a buffer. This is important, the buffering part. If you don't put that in, it's really slow and jumpy, and there's nothing worse than trying to steer off a video when there's a big delay. But I also used a queuing. This is a producer-consumer method, and that's also reckoned to be the best way to speed things up. So the producer-consumer loop, if you can read up about that, that's using these queuing VIs, Q and NQ and so on, and that seems to have an amazing effect. I can get nearly real-time video, 640 by 480 coming back to me on the robot, in full color of course as well, at about just over 30 frames per second, which although isn't ideal, it's pretty good, as you'll see later. So without more ado, I think I really need to give a little demonstration, and what we're going to do is probably drive into the corridor, turn around, come back again, and watch the images. And I'm going to use, of course, the steering wheel here. For those of you interested in that, the steering wheel part is on the main part of the project on the PC, because the PC recognizes it, but the myRio doesn't. And it's very similar to what I used before. It's but slight difference is it just uses the joystick commands: initialize joystick, read the joystick, and then close the joystick after there. Need a little delay in the loop, 100 milliseconds, and just scaling really, because it gives out plus or minus 32,768 16 bits, and I have to sort of scale it down and shift a few things. Forward and reverse was a little bit more difficult than before, so I've had to put a loop, a conditional thing in here. Okay, so we're ready for the demo now. Everything's set up. There's our little robot down there by the door. I'm going to drive him out the door, up the corridor, hopefully a little bit. And I've got this PC here, which is a Surface Pro, and its output is going to this screen. I've got my steering wheel, which is right in front of me, and I've got the foot pedal for the accelerator. So I'm actually driving here, and I watch the screen as I move. So I'm moving along, which is really interesting. And I'm just getting to the, notice the things just by the door, that's the real one. And now I'm just getting, I'm going to go out into the corridor. Oops, got a tendency to go too fast. There, we're in the corridor now. Okay, there's the other robot on the right hand side there, the big one. So I'm going to drive. You can see somebody else in his office down there. Oh, there's somebody coming out. So we'll turn around, go back to my office. There's the photocopying machine. And drive back to my office. There's always a tendency to oversteer with these things, so I'm not going too fast. I'm just my office on the left hand side there, you just see it. I can just hear it actually as well. You should probably see me in a minute as it's coming in to my office. There I am, there's my legs there behind the... Oops. Did I crash into something? No, I didn't. I'll just reverse. I crashed into the door. Oops, it's even moved the door. There we go. It should be right in front of me. There it is there. Moving. Can move quite fast, but I've deliberately kept it to be slow on this simulation. I'll just move back again. Forward. There's me. Okay, so there we go. That's how to stream the data back. Note that we're using buffers and the producer consumer loop to make it as fast as it is. 640 by 480 RGB image, which is rather nice, and it's all coming over the Wi-Fi. We're using this steering wheel here, the Ferrari one. Its actual name is the Thrustmaster, and we've got the foot pedal for the accelerator, all coming together nicely there. Thank you very much. Bye bye.